guys, welcome back to FE Made Easy. I have a cute example for you today, so let's get to work. An undisturbed sample of clay has a wet mass of 100 kilograms, a dry mass of 93 kilograms, and a total volume of 0.0491 meters cubed. The solids have a specific gravity of 2.65. The void ratio is most nearly. So I'm going to start by looking for the formula for the void ratio. So of course you would go to FE Handbook, to Geotechnical, which is part of civil engineering, and it's right at the beginning, which is great. And I'm going to scroll down, and void ratio is right here. So the formula for the void ratio is volume of voids over volume of solids. So let's go and write this down. I'll say that void ratio equals to volume of voids over volume of solids. In the problem, we are given the total volume, which is 0. Let's write it, total volume equals to 0.0491 meters cubed. And what we know about the total volume, that it equals to the volume of voids plus volume of solids. So when we find one of these two, we're going to be able to come back here to this formula and find the other one. All right, so far so good here. What I wanted to talk today was the conversation about the mass and the weight. Notice how in this problem you are given the mass as 100 kilogram and then dry mass 93 kilograms. And when we have the formulas for gamma, let's go back to the FE handbook, everywhere here you're given the weight. So gamma equals to the weight, let's say the total unit weight, right? It's equal to the weight over the volume. So if I was to write the formula for gamma, gamma is equal to the weight over volume. And I'm trying to point out to the fact, do not mistake the weight with the mass. What do you know about the weight is that weight equals to mass multiplied by g, which is gravitational acceleration. And so if you want to use the weight, then you have to make sure you calculate the weight, which is the mass multiplied by g. If you want to use the mass, you can use this formula, which is density equals to mass over volume. So you can use both of these formula, either of these formulas, but make sure you use the right component. Gamma for weight for the gamma, and then mass for the density. So that being said, now that we have pointed this out, let's calculate. I'll start by calculating the weight of the wet weight. Let's say I have the weight. This is going to be total weight, which is equal to the mass wet, right? Wet mass multiplied by g. And we have 100 kilograms multiplied by g, which is 9.81 meters over seconds squared. And this is going to give you 981. And these units, kilograms times meters over seconds squared, these are newtons. Next, we can calculate the dry weight, which is actually the weight of the solids. And it's going to be equal to the m dry, let's call it, multiplied by g. And this is 93, again, kilograms multiplied by 981 meters over seconds squared. And if you use the calculator, you should get a value of 912.33 newtons. Perfect. So now that we have these weights, we can use the regular formulas. I'm going to go with the gamma formulas. All right. Now let's see, how can we find the volume of voids and volume of solids? We are given specific gravity is 2.65. So let's see, how can we use this value to calculate volume of voids or volume of solids? Going back to this FE handbook, here the formulas, I am gonna look for so specific gravity is equal to weight of solids divided by volume of solids, which we don't have. We have weight of solids, we don't have volume of solids, and divided by gamma water. So from this formula right here, we can calculate the volume of solids. So let's do this. Let's write this formula down. Say GS is equal to weight of solids divided by volume of solids divided by gamma water. And from here, we can say that specific gravity multiplied by gamma water is equal to weight of solids divided by volume of solids. So now from here, I can say volume of solids is equal to weight of solids divided by specific gravity multiplied by gamma water. Okay, now let's substitute. Weight of solids, we have it here as 912.33. Okay, and these are newtons. And divided by specific gravity is 2.65 multiplied by gamma water. And let's go to the FE handbook. You have gamma water given here as 9.81 kilonewtons over meters cubed. So we have 9.81 kilonewtons, but here we have newtons. So I'm going to multiply it by 10 power 3 in order to transform it into newtons over meters cubed. So did you follow me what I did here? We have 9.81 kilonewtons, and in order to transform it into newtons, I just multiplied by 10 power 3. So now Newton with newtons go away. And if you do the math here, you should get that the volume of solids is equal to 0.035 meters cubed. Perfect. So now with this value known, volume of solids, we can come back here to this formula where we wrote that total volume equals to volume of voids plus volume of solids. And from here, we know total volume. We know now volume of solids. We can calculate for volume of voids. So let's say results. Volume of voids equals to total volume minus volume of solids, and we have 0.0491 minus 0.035, and this is 0.014, and these are meters cubed. Great. So we have now the volume of voids as well, volume of solids from previously calculated. We can come back to the void ratio formula and just add what we know. Volume of voids is 0.014 divided by 0.035. And from here, and say that void ratio is equal to 0.4, which is 40%, right? But the answers are given in this version here. So 0.4, the correct answer is B. There you go. Some of you had asked the question, were confused about this. And I wanted to point out what is the difference between the weight and the mass and how important it is to actually make sure you use the right component in your formulas. Otherwise, you're not going to get the right answer. If you have any questions about this example or any other examples, leave your comments in the comment section below. As always, I'm going to remind you, if you found this video helpful, please subscribe and give it a like because this helps put this video in front of more people just like you. Don't forget to keep up the good work on practicing the FE problems, and I will see you next week.